I'm going to talk to you today about Elixir. And Elixir is a functional language, and one of the things that makes it special is that it's particularly accessible for people who want to come into functional programming. So, for example, we had a whole team of Ruby developers and people who are coming from a Ruby or Python background, more like an object-oriented language. Both of these are very popular for people starting out with programming. So in our case, we had a startup. We wanted to build something very quickly. We wanted to get something going. There's a lot of tools that make this really easy. So they're very attractive options to just pick up something like Ruby or Python rather than something like Haskell. With the Ruby paradigm, what we're teaching people is to send messages to objects, because everything in Ruby is an object. So the traditional way that we do things in Ruby is to store data in state. And quite often, although we have newer frameworks like DryRB, which are teaching us to do things in a better way, quite often we still revert to these old ways of doing it. Now, 2 years ago, like I said, our team was mainly Ruby developers. We didn't have any functional, well, actually we had one functional programmer, he's here today as well. And most of us hadn't had much experience, certainly not with using functional programming in production. So we decided to adopt Elixir for a new project for a few reasons, which I'm going to talk you through. And today we now have about 5 applications in production running on Elixir. So I want to talk to you about the journey, and I want to tell you why I think it's such a great stepping stone for people who might want to get into functional programming. So if you're a big fan of functional programming, if you're looking for a way to convince people, other people to give it a go, then hopefully this might help you find a way to get more people into it. And if you've been wanting to give it a go and you haven't found a good way in yet, then maybe Elixir is a good choice for you. Now, I work for CultureAmp. We have a product which is essentially an employee feedback platform. And it allows companies to set up an employee feedback strategy, essentially running a whole bunch of different surveys, employee engagement, individual 360s, manager and team effectiveness, and so on. And we present the data back in the form of individual reports, interactive reports. So users can filter, analyze, take action on their results. This whole application started life as a Rails monolith. And we had 4 or 5 developers working on it, so as you can imagine, it wasn't too bad. At that size, you can keep the whole application in your head, everything it does. But after a few years, we raised some money, and we started growing our development team and hiring like crazy, and it really wasn't very long before this monolith started to get out of control. We didn't have very good boundaries, and we were just treading on each other's toes. Every time you built something, you'd break something in a whole other area of the monolith. So we took a long look at our technical strategy at that point, and we wanted to make some decisions. We wanted to move towards microservices, because who doesn't? And we wanted to take advantage of different languages and frameworks. So rather than always building everything in the same language, try and find where some languages or frameworks would do a better job of the thing we were trying to do. So we considered our options for this next project. Elixir made sense for a few reasons. First of all, because it's really, really good at concurrency. Compared to Ruby on Rails particularly, the closest we were getting was running a web server that had multiple threads, because it's really hard to build concurrency into Ruby. Elixir runs on Erlang's Beam VM, and this is built from the bottom up to support multiple processes. It's really cheap to spin up new processes in the Beam VM. And Elixir does not allow you to change the state of objects. So it's much easier to reason about things in Elixir, because all you're doing is passing data from one function to another. There's no danger that you could be modifying something that's then being used in a different process. The second thing was accessibility, and as I mentioned, we had a team of Ruby developers, and it was really important to us that we didn't pick something up where all of our developers wouldn't be able to be productive in it for 6 to 12 months. We wanted to be able to get ready, build something quickly, and actually get it working in production. So this was really, really important. Performance was the third reason. And this may seem a bit odd to some of you, because Elixir, compared to languages like C++, is really not your top choice for performance. And in the Ruby world, however, it really had a great reputation for performance. This is largely because it's so good at concurrency. You can actually build applications that are much, much faster in Elixir than you could in Ruby or Ruby on Rails. And the last consideration for us was its impact on hiring. We wanted to be able to hire a lot more developers like every other company in Melbourne, and we were hoping that by doing something new like Elixir, it would give people more of a reason to come and work with us. Oops. So you might be thinking, why didn't we just write Erlang? I mean, after all, Elixir runs on the Erlang VM. Why not just use the language it was built for? There's a few reasons for that. When you work with Elixir, you get the benefit of not just the Erlang VM and all the Erlang libraries, but you get all of the Elixir libraries which are built on top of it. You get the beautiful Elixir language as well. And the syntax of Elixir is superior, many would say, to Erlang. If you think about Elixir was based on a bunch of other languages, including Ruby. And if you think about what Max was trying to do when he built Ruby, he really had developer happiness in mind right from the very beginning. And DHH, when we built Rails, was trying to build something that would appeal to the masses, all the programmers who were new to the language. And Elixir has learned a lot of lessons from this. It's taken a lot of its syntax from Ruby. So as a Ruby developer, it really feels very nice coming to work with Elixir. And they've thought a lot about the libraries. So you have a lot of the nice kind of syntactic sugar that you have with Ruby also built into Elixir. And the other thing that Elixir gives us is a set of meta-programming tools. So if you like doing that with Ruby, if you're coming from an object-oriented background or other languages where you enjoy meta-programming, then you're going to enjoy that with Elixir as well. Now, as well as the steeper learning curve with Erlang, if we'd chosen to use Erlang, there's a lot more boilerplate code that you have to write. And Elixir takes a lot of that away from you. So rather than having to think about all of this boilerplate and work out how we actually write this code, we could just get stuck straight in with Elixir and start writing our applications. Now, I'm talking a lot about Ruby, and I want to make the point that Elixir is not Ruby for Erlang. It is an entirely separate language. It's a language all of its own. You get the best of Ruby and the Erlang world as well by using it. But it really requires a bit of a paradigm shift. So when you first start using Elixir, you can get going very quickly. It's very familiar. But until you shift how you're thinking into a more functional programming way of thinking, a more Elixir way of thinking, you don't quite get the best of it. So let's talk about our journey. I'm clearly pressing these buttons just way too hard. We had a lot of expectations when we started out about how good our life was going to be when we started writing Elixir. And one of those things, like I mentioned, we were thinking, great, we can write programs with much better concurrency. We can make use of concurrency to make things work much faster. Concurrency is when your program is doing multiple things at the same time. So when we tried to do this with object-oriented code, we had to manage it very carefully, because if we had two separate threads trying to edit the same object, trying to change its state, then we could end up with a different result from one of those methods than if they did it in the other way around. The outcome of our functions in Ruby often depended on the state of the object at the time we were calling that function. But when we went to write Elixir, we were just writing these nice pipelines, passing data from one function to another. And we had a lot of pure functions which are idempotent. Every time you pass in a piece of data, you get the same result out the other end. So with that in mind, it didn't really matter if we had lots of different processes. It didn't matter which process we used to call these methods, because we'd get the same result either way for any given piece of data. The Beam VM, as I mentioned, is set up to manage multiple processes. It's very, very cheap to spin up new processes in the Beam VM. It's designed to support massive parallelism, and it's as cheap to spin up a new process as it is to spin up a new object in an object-oriented language. So in order to truly support concurrency, though, the VM has to know how to deal with failure. So if an exception occurs in a process, it doesn't take down that whole process. We had things occur with our Ruby applications, for example, in our web server, and we had exceptions that weren't being handled that would take down the whole web server process. If that happens across all of your web server processes, then that server is no longer responding to requests at all, which can be a big problem. Now, the Erlang VM makes sure all its processes are isolated, so if one of those dies, at least it doesn't take the other ones down. And all of these properties meant that Elixir is a really good language for writing things like web servers and web applications. It also has this thing called OTP, which is an Erlang framework that's included with Elixir. It stands for Open Telecom Platform, because that's what it was built for originally. But it's not really something that it's used for anymore, so we try and just think about it as a word. And I think as Erlang in Action, they suggest that the better name for it is actually Concurrent Systems Platform. So when you hear OTP, this is what we're referring to. It's a Concurrent Systems Platform. It's a set of libraries that can help us to write applications that use concurrency. And the framework that it provides allows us to structure our applications into a set of supervisors and workers. As the name suggests, the workers are the ones that are actually carrying out all the work within your application, doing all the hard stuff. And the supervisors start processes and they manage them, so they know what to do if one of those processes dies. And so we used OTP and Elixir, we built on top of it. And this meant that when we were able to start creating our systems and our applications without having to worry about how we design all these processes, how we manage them, we could really just jump in and start thinking about what's our application got to do and use this OTP library for everything else. We use supervisors in a lot of applications as well. The very first one, we had a number of different event streams, and so we had a separate worker that would be processing each event stream so that they could all be happening in parallel. The events needed to be processed in order, so we couldn't have multiple workers on them, but we were able to at least parallelize all of the different events. And because OTP is it's really battle-tested, this thing's been around for years and years and years, so we didn't have to worry too much about having a lot of bugs creep in from that. The bugs that crept in were in our application code, but at least we didn't have to worry about how we were managing these processes. We've got a more recently built application as well, and what it does is takes people's comments from surveys. So every time you say something in answer to a question, a free text question, it can look at what you said, and it can tell what you're writing about, what the topic is, and it can tell whether it was a positive or negative or a neutral comment, and apply those classifications. Doing one comment at a time doesn't really take very long, but overall, doing many comments is really time-consuming. But it doesn't matter. The outcome is not changed by one comment being processed in front of another one. So we were able to spin up 60 separate workers to process all these comments. Now, when we had several million, when we first started this application up, we had a big backlog. It took about 60 hours. So you can just imagine if we hadn't have been able to parallelize all of those workers, how long it might have taken us to process all the comments. And we get spiky traffic to our platform like any application out there. Sometimes somebody spins up a new survey and we get like those bumps of people completing it when it first goes out. So we need to be able to spin up the number of workers and then close them down again to do things like this within the application as and when we need to. And so Elixir has been really great for us to be able to do that. Now this is what we use for Ruby on Rails. We have the monolith. We use Unicorn so that we run a number of separate workers for the web server. And then we have this application called which monitors the web server workers. And what we found was when you set this up at the beginning, you configure it all, you have to learn how to do it, you do it once. And a year later when something goes wrong with it, nobody actually knows how it works. You have to go and read all about it again and set it all up and figure it all out. But with Elixir, the difference was that because OTP was part of the core part of our code that we were writing and interacting with every day, it was a lot easier than having to manage 2 or 3 separate applications just for running the concurrent web servers as we were doing in Ruby. But it wasn't always great. And I wanted to tell you one story from our early use of OTP. And we were connecting to a Mongo database. And about half of you are going, well, there's your problem right there. But we were using this library from Elixir to connect to this database, and it was supposed to be just copying events from the Mongo database into a Postgres database. And it would be working fine, and then we'd go home on Friday and come in on Monday morning, and it stopped. And we didn't know why. There was nothing in the logs, and we thought, well, this isn't right. OTP has these supervisors and workers. It's supposed to restart the processes when they die. Why is this thing just stopping? And it took us a couple of weeks to figure out what was going on. What was happening was the Mongo library we were using was actually timing out in its connection to Mongo. But rather than saying, okay, this is an exception, this is wrong, which would have caused the supervisor to restart our worker, it was just going, oh, okay, I can't connect, and I'm done. And it was closing the process off in a less obnoxious way, if you like, closing it gracefully. So the application didn't know that it should start that worker up again. This was a bug in the application. In the library that we were using, it was quite possible that it had just never been used with the same version of Mongo we were using. We don't really know how well tested it was. So some things we learned. For Elixir, the SASL logging library is amazing. We were without this for a couple of weeks before we discovered it, but as soon as we put it in, it was really, really clear to us exactly where the application was going wrong and what was going on. So if you try Elixir, then the SASL logging library is your friend. We also learned that workers that stop gracefully, that are closed as though they've done their job, they don't get restarted, which was something we hadn't really realized. And the other 2 things, more just general learnings, because we were using a language that was not as widely used, it was much harder when something went wrong for us to go and figure out from the internet, from asking Stack Overflow, what was going on. So if you're going to try something like this, a language that is not as widely used, as well known, as established, you need to be prepared to expect the unexpected. You need to be prepared to be able to dig into the libraries, figure out what's going on, try a bunch of different things yourselves. And Ruby developers, I think, we're a little bit spoiled. We're very used to just being able to Google the error message and find the answer. So this was a learning for us. Now, I mentioned that accessibility was a really big deal for us, for people being able to get into Elixir quickly. Now, at first glance, it does look a lot like Ruby. It looks really, really familiar. So it's quite easy for our Ruby developers. They had no experience of Elixir. They can follow what the code is doing. You don't really need to understand all the ins and outs of it. And I think this is where functional programming, especially for me, had been a big barrier, a big hurdle to get over to start getting into. But Elixir really made that a much lower hurdle. You just, at the beginning, kind of have to think, well, where do I store my results that are coming out of these methods? We don't think about that as much in Ruby. So you start thinking about everything as just an object with a functional interface. And that's a good enough way to start off. These are some of the similarities as well between Elixir and Ruby. We have maps in Elixir, which kind of look like hashes when you first start using them. Lists kind of look like arrays, and you can think about them in a similar way. Atoms, the equivalent of symbols. Enum and stream both have a very familiar interface in Elixir compared to Ruby. So we had a mind map of all of these concepts. We were able to just use that and really navigate and understand the Elixir code much more easily. We didn't need to think deeply about what it was doing. We could just get going with building our applications. So it was this really nice, pleasant, gentle journey. And then we really started to fall in love with Elixir when we started discovering what was different. And you have a kind of paradigm shift where you're really, like I said, thinking, oh, this is just objects with functional interfaces. I'm just passing data around. But then you start to understand some of the power of what the different things it can do. The more that you write Elixir as well, what I found was that it actually teaches you how to write better code because it has functions and features within it that once you start using them, you start writing better code with them. And this was one of my favorite parts of it. I started longing for some of these features. When I went back to other languages, I really missed them. The first one I want to talk about is the pipe operator, which looks like this. Now, when we write code with no pipe operator, essentially what we're doing is passing the output of one function into the next one. So sometimes we assign it to a variable, or we might nest functions, and it starts to look a little bit ugly like this. Once you get a few functions chained together, it's very quickly quite hard to read. So we start abstracting functions out from these chained functions. We start having functions that do this and this. And then it's really hard to name them, and the names get really long and really nondescript, and eventually we've just got this spaghetti code that is very, very hard to follow. However, the pipe feature in Elixir means we don't have to do that. We can just have this long list of functions that we're passing the data from one to the other. And it's so easy to read. It was really nice to see the code looking like this, and it's really nice to follow. It follows the convention where the subject of whatever you pass to the pipe becomes the first argument to the next method. And so it was really, really easy to decompose all of our functions into pipelines. We ended up with a lot of one-line functions. They're really easy to test. They're really easy to see bugs in, really nice and easy to read, and very maintainable code. The second thing I wanted to talk about was pattern matching. Now, in Ruby and in a lot of other languages, the single equals operator is used for assignment. When you do x equals 1, what you're doing is assigning the value 1 to the variable x. And we're used to that pattern as developers. But in Elixir, a single equals is a match operator. You don't need to understand this. When you first make the switch over to Elixir, most people just see it as an assignment operator. The real difference when you first start is just the error messages are a bit weird. But pattern matching is super powerful. It's one of the best things about Elixir. It gradually taught us these new concepts like pattern matching, these better ways to do things. Now, when we write x equals 1 in Elixir, what we're actually doing is asking the program to match the two sides of the expression. And if it does this successfully, then it returns the output of the expression. A successful match happens either if the two sides are equal, or if it can bind the variable on the left-hand side to the value on the right-hand side, which in this case it can. So I want to illustrate this with a video. Is it playing? Now Now, if you tried to write 1 equals 2 in most programs, that's just stupid. That's invalid syntax. The program won't even run. But if you try to write it in Elixir, it will actually try and evaluate it. It's valid Elixir code, even though it's really dumb code. And what it just returns there is a no-match error, because you can't assign 2 to 1. You can't make them equal. Now, this gives us some handy tricks. So you can do things in pattern matching like pulling values out of a map. So if you can match a key within a map, then it will just pull the value out of that. It's kind of nifty. Wrong conference, but sorry. No hands. And we use tuples a lot as well in our code in Elixir for collecting the output of a function and the return value. So did this thing actually, if you tried to get a value back from a web service, did you actually get a value back? Did it return okay? Did it return an error status? And then the other variable would be the contents that you got back. And you could do a nice pattern match with if statements. If you actually get an OK result, then you can just match a variable to the other result that you get back. This is all nice. It's not particularly special. Ruby does a lot of nice shortcuts to make this easier, but it gets better. Now, Elixir is optimized for recursion like closure. Ruby's more optimized for iteration. So when we were more used to thinking about iterating through lists, whereas Elixir's lists are actually linked lists, this was a bit of a change for us. We had to start thinking about, well, you can't pull a numbered item out of this list like you can with an array. But we had to start thinking about calling functions over and over for the same list. And one of the nice things Elixir gives us is, did that run? Oh, sorry, is the ability to pull like the head and the tail of a list. So you can just assign head and tail. And if you've got an empty list, then your tail returns just an empty list. You get nothing for the head, you get an empty tail. And if you have a 1 item in a list, then your tail is an empty list as well. And so it enables us to do things like this. This is just trying to find min and max from a list, because I was thinking, wow, questions in the middle. I didn't know there were questions in the middle. By pulling just the min and max out, we could have these really nice clean functions, and using pattern matching, when it's an empty list, then we know that whatever is in the head is going to be the maximum value. And we can also use pattern matching as like guard clauses on functions, so that the function doesn't have to have an if statement inside it. We could really make the code much, much shorter. And you can use pattern matching for types. So if you're like, no, Elixir, it's got no types, then it sort of has some. So these are just a few of the benefits we started seeing once we adopted some of these patterns. We had fewer nil checks. We had fewer if statements in our code. We eliminated early returns. We didn't have any early returns in the functions. They were much shorter, and they were just much tidier and much prettier and nicer to read. And of all the things, when I switched back to Ruby, I think pattern matching and the pipe were the 2 things I was like, when can we have this in Ruby again? Now, I want to talk a little bit about state, because Elixir does not allow us to mutate state. There's just no such thing as a mutable object. So you can rebind variables. Unlike some functional languages, you can actually rebind a variable to a new value. But initially, when you switch, if you're used to using mutable state, then it's a little bit jarring. You kind of, like I said before, where do you put the outputs of these functions? But it made concurrency much easier to support making this change. And it also meant that as we started to write more code this way, we got better at it, and the benefits became more obvious. So when we went back to our Ruby code and to our other JavaScript code and so on, we were writing much cleaner code, fewer side effects, and just it was much nicer seeing the benefits of what we've been writing in Elixir were coming into our other code that we were writing as well. And Elixir comes with some great tools. These are 4 of our favorites. Mix is the tool that we use to create and manage projects and to manage dependencies. And it's been influenced by Bundler from Ruby and Leiningen from Clojure. So it has a lot of functionality as well from Ruby's rate tool. You can write mixed tasks. IEX is the interactive Elixir, the REPL for Elixir. It's got some nice features. Things like typing H gives you documents for any function that you want to look up. And Logger is built into the language. It can be imported as a macro when you're writing Elixir. One of our developers said, it is just like the best logging tool. He was very emphatic about it, not that easy to please either. And he was just saying, this is the best logging tool I've ever used. And I think because it was really a core concern for the developers, it was built in from the ground up. So it's just got enough functionality, and it's a really, really good tool. Lastly, XUnit. So like many languages, testing is built in from the ground up with Elixir. XUnit is the testing package that comes with it. Now, Elixir is a relatively new language still compared to a lot of others. And its creators were able and willing to take a lot of lessons from lots of other languages. Yeah, Elixir is what would happen if Erlang, Clojure, and Ruby somehow had a baby and it wasn't an accident. The syntax and spirit of Elixir is largely Ruby inspired. Like I said, a lot of the syntax is very much like Ruby, and it's built to appeal to developers to make it fun to use. It's got some of the best Erlang features built into it, so pattern matching, which was originally inspired by Prolog. It's got Erlang syntax for data structures as well. Its protocols are inspired by Clojure protocols, and the derive feature has come from a similar feature in Haskell. Then it has doc strings and doc tests, which have come from Python, and the pipe operator actually came from F#. So you can see that they took a critical look at all the other languages and thought, well, what are the things that make these languages great and that people like using, and how can we build these into one language and make it really great? And so creating something that's that powerful and easy to use and actually accessible to a large group of developers, including newbie developers, I think that's no mean feat. I think that's pretty cool. So I hope I've sold you by now on how great Elixir is, but just to reiterate, when we started on our Elixir journey, it was a pretty immature language, and we decided it was stable enough to use in production, which it was. It's done us really well for our production applications. But just to keep in mind that when you're using such a new language, there is often a lot of work to do learning yourself. That some people are very happy to do that, but it can be a little bit jarring, especially for newer developers. So you've got to expect that it's going to take you longer to solve problems. You won't be as able to find the answers to all of your problems online as easily as you can for some other languages. We had one issue where we went backwards and forwards with test frameworks because we just got to a point where we could not figure out how to do what we wanted to do with eSpec. So I wouldn't shy away from using a new technology in the future, but I think it's important that if you're going to do it, and particularly if you're trying to persuade your company to do it and for your production applications, just make sure that you know what to expect and what you're getting yourself into. So we're a year more than that, about 2.5 years now into our Elixir journey. We've got a few more grey hairs. I still think it was the right decision for us. I think it has helped us with hiring. I think it's been a lot of fun for our developers. They've learned a lot of new things, and it's made our other code better overall. So I'd say it's been a success. And it's also been great to see the community growing and more things being built and developed. So I'm really happy about that. I'm looking forward to the future. Thank you.